Okay, this is my first attempt at standard 4.1. For this, I decided to do problem 4.3. Would ask us to consider the two-particle entangled state phi equal to 1 over the square root of 2 times the ket plus times the ket minus the ket negative plus times the ket positive. We're asked to show the probability of observer A measuring particle 1 to have spin up is 50% for any orientation of the Stern-Gerlach detector used by observer A. We are told to find this probability. We can sum over all the joint probabilities for observer A to measure spin up and observer B to measure anything. So, let us say that the observer A records a plus along what we will define as the z-axis. Let's also assume that observer B measures along a direction n hat at some angle theta with respect to the z-axis. To start, we will find the probability that observer A along the z-axis and observer B along the n direction both record a plus. Thus, we use this formula right here. Substituting the entangled state and the direction eigenstate into this formula, we get this right here, which will then simplify to this, which we ultimately end up getting a probability of them both finding plus plus is 1/2 sine squared of theta over 2. Again, we follow a similar process for plus negative. Following the same steps above, we simply get 1 over cosine squared times theta over 2. And then to find the probability of any orientation, as we are told, we can just simply add them together, which gives us 1/2 sine squared of theta over 2 plus 1/2 cosine squared of theta over 2. Which for any theta you plug in will give us 0.5, which is what we were asked to show. So we successfully did that.